Number 21 asks us to take a look at the graph of the derivative of f of x. For what value of x does f of x have a relative maximum? So we're trying to figure out on the original function f of x, when do we have a relative maximum? So first we have to ask ourselves, how do we know when something has a relative maximum? Well, that happens when the first derivative changes from positive to negative. And we have a graph of the first derivative, so we can figure that out. When does this graph change from positive to negative? Remember, y equals the derivative of f of x, so the y values on this graph represent the derivative of f. So these y values up here are all positive, and the y values down here are all negative. Since those y values are negative, that means the derivative of f of x is negative. And up here, the derivative is positive. So we want to know, when does it change from positive to negative? Well, here it changes from negative to positive. Here it changes from positive to negative. So this point right here at x equals 2, we would have a relative maximum. Negative to positive, and then positive to negative. So at 2 and 6, we have two different places, but our only choice here that works is 2. Another way you can do it, if you feel more comfortable, you can look at it on a number line. Create a number line for the first derivative. We know the derivative is 0 at these points. 0, 2, 4, and 6. And then plot what we talked about earlier. Here the derivative is negative because the y value is negative. Then it's positive, negative, positive, and negative. And looking at it this way, it might be easier for you to see, okay, there's a minimum here, maximum, minimum, and maximum, because when we change from negative to positive, decreasing to increasing, we have a minimum. Change from increasing to decreasing, we have a maximum.